A bob on a 0.6 meter long string is rotated in a vertical circle when the bob is in the position when the string makes 45 degrees angle above the horizontal. Centripetal acceleration is 28 meters per second squared. Find the tangential acceleration at this point and the speed of the bob at the top point of the circle. Okay, we have to draw that. Here's the drawing of that bob at the top of the circle. Here's a drawing of the bob at the angle of 45 degrees. So we have centripetal acceleration. That centripetal acceleration will consist of two parts. One part is the projection of the gravitational acceleration, this part, and the other part constant part of the centripetal acceleration that we don't know at this time, but it has to exist because this bob moves in the circle. So let us see how much is tangential acceleration. This is under 45 degrees angle. That is not very difficult because only tangential acceleration in this kind of motion is actually projection of the gravitational acceleration on a tangent. And that is because that is angle of 45 degrees. It is exactly the same as tangential as a projection on the normal, projection of the gravitational acceleration on the normal. So centripetal part of the gravitational acceleration and tangential part of the gravitational acceleration is the same in this case, and that is square root of 2 divided by 2. Why is that? Because that is sine and cosine of 45 degrees angle. So that part is the same. Okay. Here you have radius, here you have sum of the centripetal acceleration that consists of constant part of the acceleration and the projection of gravitational acceleration. This is the sum. This part we have in 45 degrees. This part we have, it's given in the assignment, and this part is calculated here, and this is unknown for us, but doesn't matter. This is the answer under A. Tangential acceleration is actually just a projection of the gravitational acceleration in tangential direction, and that is square root of 2 divided by 2 times 9.81 meter per second squared. That is the number. Okay, for the speed at the top of the circle, we will use this or another way constant part of the gravitational acceleration. Because why? Because that tangential part in that situation is 0. There is no projection of gravitational acceleration on tangent at the top and at the bottom of the circle. So we have to find this acceleration, that constant acceleration. We have this and we calculate this. This is the constant acceleration this is the constant part of the centripetal acceleration that exists everywhere. And on the top and the bottom, this is the only thing that exists. Okay, and now you use this you use this acceleration as the centripetal when the bob is at the top, and then you easily calculate the speed of the bob at the top. There is complete written answer, and if you want it, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Bye.